Hello everyone again. Welcome to Lab 7 and today we are going to discuss about submaximal exercise and testing. Now, as we have been discussing throughout, we'll talk about the presentation outline first. But if you have noticed that in the first two questions, I have interchanged the sequence. I will talk about what is submaximal exercise testing at the beginning, and then I'll ask you to think about the importance of this topic, and then of course I'll answer that question. We will then discuss some of the graphs depicting training adaptation, which will help us to decipher graphs a bit. Then I'll talk about some of the important things related to submaximal exercise testing, which are some of the assumptions, some of the sources of error. We will just recapitulate RPE, which is the rating of perceived exertion, and then I'll also talk about some of the indicators of stopping the exercise, which I have discussed before in the practicals, but again we will revise them quickly. And the things which you're gonna do in our lab today are the Queen College step test, the first test which we are gonna do on a bicycle ergometer, and the Ebeling exercise treadmill test, which you're gonna do on the treadmill. So today we are gonna do two tests and then fill in two data sheets and compare your finding with the normative data. So the things which are there highlighted in red are the important stuff, and I'll talk about them in a lot of detail, and we'll do it today. Today I also included a slide to just outline two big objectives, which actually I have already talked in the two highlighted red points in the presentation outline, but still I want to repeat them quickly. You have to do or perform submaximal exercise testing and utilizing the collected data from that test to estimate VO2 max and compare it with the normative data table values. So we are all set to begin our class today, and let's start with the definition of submaximal exercise testing. Now, the idea is very simple. You are going to work somebody on a treadmill, a bicycle ergometer, or any kind of cardiorespiratory exercise, and you increase the workload in an incremental or graded fashion, but not to the point of exertion or not to the point where the person can do it anymore, but you will stop before that. Keeping this discussion in mind, if you see the definition here, it says that incremental workload ending before, just highlight the word before, extreme exertion. So you are going to make him work, but try to finish the stuff off, stop the exercise before that person gets completely exhausted. So, knowing this definition of submaximal testing, let's move on to talk about a quick difference between the maximal testing and the submaximal testing. I feel that it's pretty important to know the clarity of the term before we discuss a huge detail, exhaustive detail about that particular topic. So, maximal exercise testing means that if we are increasing our workload to the point of failure, to the point where the person can't do it anymore, versus the submaximal testing, which I have just talked, which means that we will end or stop the test before extreme exertion. So it's just before or just when the person says that he can do it a bit more, stop the test. So point of failure versus before the point of failure. That's maximal versus submaximal. So knowing the difference between two types of testing, let's talk about that why this testing is important and why as a kinesiology undergrad student you should know about submaximal exercise testing. You can pause the video as always, think about it for a couple of minutes, come up with some points, jot it down on a paper, and then see what are the answers. And again, I'm repeating, if you have a couple of matches, you are really doing a really good job. So these are some of the points which I find this topic important. The first one, it is more practical to perform, especially on people who are untrained. If you find people who are untrained, if you find people who are of old age, if you find people who are not doing exercise for a longer period of time, this is the right thing, because if you try to do maximal testing on them, it is sometimes can cause injuries. It's not as safe as the submaximal testing. And we can get a bunch of information out of this submaximal exercise testing about that particular person. For example, the things which I have highlighted in blue, that people can check the aerobic capacity, we can check the cardiorespiratory fitness, we can also check for VO2 max of that person. Also, we can record heart rate, blood pressure, and the RPE. So keeping in mind all these measurements, we can comment on the respiratory system and the cardiovascular system, which are working in tandem with each other to provide oxygen to the exercising muscles. So the overall health of the combined cardiovascular and respiratory system can be assessed using this submaximal exercise testing, and that is why we are doing it in our lab. Great. So what we are looking in this test, I've already talked. A quick revision: we can get blood pressure, I've already talked. We can get heart rate using the radial pulse, as always. We can also calculate time, the time through which a person can continue doing this exercise, and we can also talk about the work rate, that in how much time the person is able to achieve a certain amount of power. And I've already talked just a while back about the RPE. So keeping in mind these parameters, we can comment on the health of the cardiorespiratory system of that particular person. Now, as I've mentioned in my previous presentation outline, that we will have a couple of graphs to discuss. This is the first one. As we have two graphs to discuss, I want to highlight a couple of points related to reading, deciphering, and interpreting of graphs. So the first point is that if you see any graph, just do four things, no matter what kind of line graph or a bar chart it is. First, read the heading on the x-axis, then go and see what is there on the y-axis, see the units, and continue reading the x-axis and try to see the values which are related to the y-axis relating with the x-axis. So technically it means, for example, if I'm seeing the percentage of VO2 max here, then at 25 we have a value of heart rate which is 90. Of course, it's possible to say that at 90 the VO2 max percentage is 50, but 25, but generally we read the value from the x-axis first and then try to extrapolate it on the y-axis. So I'm going to follow this pattern for both our graphs, and you can do it for other graphs which you'll read in future as well. So in this graph, this is pretty interesting. We know that the submaximal fitness is directly proportional to the heart rate, and the heart rate is directly proportional to VO2 max, or the maximum volume of oxygen consumed per minute. So if we combine both these equations, heart rate here and heart rate here will get cancelled, so that we can get an equation that submaximal exercise is directly proportional to VO2 max. We cannot assess VO2 max directly here because we are not putting a mass, we don't have a metabolic cart attached, but we can assess submaximal testing by correlating it with the heart rate, and because heart rate correlates or is directly proportional to VO2 max, we can always say that submaximal exercise is directly proportional to VO2 max, and we can comment on someone's VO2 max keeping his submaximal exercise testing into perspective. And this is known as an indirect extrapolation, where we are assuming a similar trend, keeping in mind the current status. Now, using the information which we have in our previous graph, now let's try to decipher this particular graph. Again, I'm following the same trend. On the x-axis, we have the power in watts, and we have the oxygen uptake in liters per minute, and on the y-axis, we have the heart rate. In this graph, the stuff which is highlighted in red is of an untrained individual, and the line which is highlighted in blue is that of a trained individual. If you see at the power, let's say it's 210, we can see that to achieve a power of 210, a person who is untrained in red will need a heart rate of approximately 185. But the similar amount of power is achieved by a trained person in just around 165 or 70. So a person can achieve more power with less heart rate, or more power with less power with more power of the heart in a less amount of heartbeats. And the similar thing is happening, that that person who is trained can achieve this at 250 watts at approximately 185 beats per minute, and his overall maximal capacity has increased. So the idea is that whenever we do exercise or do training, then our ventricular muscle mass increases, which means that our heart pumps more blood with each beat. That is why we need less heart rate or less number of beats to achieve the same amount of blood pump, because the stroke volume or the amount of blood pumped with each beat increases in trained people because of increased in ventricular muscle mass. So if you just combine this whole graph, it's written as people become fitter, their heart rate decreases at any submaximal work rate, and heart rate decreases. I'm repeating it again because with each beat more blood is pumped, so the overall amount of blood remains the same. Now, these are a few assumptions which we assume while doing this test, and I've highlighted them one after another. The first one says that the subject reaches steady state exercise at each submaximal work rate. So the idea is that once a submaximal state is reached, then the measures of heart rate and blood pressure also attains a steady state and then can be recorded. Now, the interesting point here is that all the subjects expend the same amount of energy or VO2 max at an absolute given work rate, no matter what their fitness level is. So the fitness level can vary amongst individuals, the individual maximal capacity can vary. However, they will spend same amount of energy at any absolute work rate. And in order to calculate the maximal heart rate, which is given in point 3, which you need for your data sheets, it is a formula which is 208 minus 0.7 multiplied by age. So for any given age, let's say your age is, let's say, 20, then you are going to achieve a maximal heart rate of whatever value is going to come. So at any particular age, the point which I've highlighted before, this is the maximal heart rate which you're going to achieve. Now, this varies with individual, that what your fitness level is and how much energy you need to achieve that heart rate, but the heart rate is constant at every possible age. Now, this is pretty simple. These are some of the potential sources of error which can happen once you are doing this practical. So I just thought to highlight a few. Step height can vary, or there is inaccurate step cadence, which you can definitely eliminate because we are putting 3 boxes. Length of each box is measured. So as long as you are putting the right number of boxes for your exercise, I guess you'll be fine. And what these boxes are and how we are going to keep them for exercise, I'll discuss once I'll talk about the step test. Now, you can have accurate work rate, you can have an inaccurate workload on an ergometer, and you can have inaccuracy while recording the heart rate and the blood pressure. So the idea of this slide is to just make you aware the potential sources of error which can happen once you are making somebody exercise as far as these 2 exercise tests are concerned. So just be aware of these points and be a bit careful while making that person exercise and recording these measurements. This I have highlighted before, discussed before. Just a quick recap that RPE is a rating of perceived exertion. It's also known as the 15-point scale. It is given on page number 161 of your book. So once somebody is exercising, this is a subjective phenomena. You ask the person on a rating of 6 to 20, it's a 15-point scale. He can say, I'm feeling 6. It's just like a piece of cake. He's doing exercise and he feels that he's just doing nothing. If it's 15 to 16, it means he is working hard. And 20, this is the maximum amount of work that person can ever do. He just can't be pushed beyond that limit. So the person can perceive how hard or how difficult he's exercising based on this 15-point Borg scale. This is another box which I have discussed before in the blood pressure practicals, that what are the indications of stopping the exercise. I've highlighted the stuff in red, which I feel is the most important, and you are likely to encounter this in your professional careers. So if you see a drop in systolic blood pressure, especially less than 10, try to stop the exercise, try to consult the physician, try to get a clearance before you make that person exercise again. Also, if there is excessive rise in blood pressure, let's say more than 250 systolic and more than 115 or 20 diastolic, this is again a kind of a hypertensive crisis situation. I've already talked that before. Stop the exercise. You will make the person suffer if he continue doing the exercise. Or if you see that there are symptoms such as lightheadedness, confusion, pallor, cyanosis, the bluish discoloration of skin and mucous membrane, stop the exercise. Or you can see that there is a drop in the heart rate. Again, it's an indication to stop the exercise, because as you have remembered, heart rate is going to increase no matter which type of exercise you are doing. If it's dropping, there is something wrong. Now we have come to the most important and interesting part of our presentation today. The 2 big step tests which we are going to perform today. And the first one is the Queen's College step test. So I will walk you through each step, and once you will do this test, it will definitely make more sense to you. So, as the name suggests, it's a step test. So you are putting steps for the person to do the exercise, and here we are putting steps by putting three boxes one over another, and the total height of the three boxes combined will be 41.25 centimeters. You don't have to bother, or you must know about the height. As long as you are putting three boxes the right size one on top of another, you are good to continue with the test. The participant will rest for 3 minutes. So before the test, make him rest for 3 minutes, record the heart rate using the radial pulse for 15 seconds, multiplied by 4, and you will get a heart rate at rest. Then we are going to set the beep through an instrument which is known as metronome. So it will provide you a frequency on which the person is going to climb up and down the steps. So we have different beep metronome values for males and females. So if you are a female, make her step at 88 beats per minute, and if you're a male, you have to do it a bit more faster, which is 96 beats per minute. So you will set up the metronome, put it 88 or 96 beats depending upon the gender of your subject, and then the participant is going to climb on the longer edge of the box. So the box is a rectangle like this, so you will set it in a way that the person is going to climb on the longer edge of the box. And the point which is highlighted in red afterwards says that each beep should be a step on or off the bench, which means that if you hear a beep, the person will step on the box. Once he's heard this next beep, he gets off the box. So with each beep, he is either climbing on or he is getting off the box. And this exercise is going to continue for 3 minutes. After 3 minutes, just wait for 5 seconds to start palpating the radial pulse and record the pulse from 305, which means 5 seconds after the test up till 20 seconds after the test. So record the pulse rate for 15 seconds, multiplied by 4, and get the heart rate immediately after the exercise. And that heart rate we are going to use to predict the VO2 max using the recovery heart rate, and I'll discuss that in just a bit of a time in the data sheets. If you want to summarize this whole test, I can just talk about it in 3 sentences. Rest for 3 minutes, record the pulse for 15 seconds, set the metronome, females 88 seconds, male 96 seconds. The person will do the exercise for again 3 minutes. With each beep, he is stepping on. With next beep, he is stepping off. And this will continue for 3 minutes. Once the exercise is over, use 5 seconds to find the pulse and record it for the next 15 seconds to get the recovery heart rate, so that we can indirectly use it to measure VO2 max. So we are done with the Queen step test. Now, we are there at the end for our last test for today, which is the Ebeling Sub-maximal treadmill test, and we will use treadmill instead of bicycle ergometer, which instead of the steps which we have used in the Queen step test. For this one, first you have to determine the heart rate max using the same formula which we have just talked, 208 minus 0.7 into age in years. Take the resting blood pressure and the heart rate and set the walking speed on the treadmill to 3 miles per hour. Now, it's a very simple test and I have highlighted it in your PowerPoint, so you should be exactly aware what you're going to do. The warm-up is for 4 minutes. So the speed of the test will remain 3 miles per hour throughout the 12 minutes test. So you are the belt is moving at 3 miles per hour, but because we are doing the warm-up, the inclination or the grade will be set at 0%. But you will record the blood pressure, the heart rate, and the RPE at 2 minutes and then again at 4 minutes. So the warm up is of 4 minutes with BP, heart rate, and RPE recorded at 2 minutes and 4 minutes. The moment we have entered minute 4, then just change the grade or height or inclination. Speed will be the same, it will be 3 miles per hour, and we will do the exercise at 5% grade or inclination for another 4 minutes. And again, after 2 minutes of exercise, which means it will be 6 minutes after the test or 2 minutes after the start of exercise, again record blood pressure, heart rate, and RPE, and do it again at minute 4 for the exercise or minute 8 in total, the same 3 measurements of blood pressure, heart rate, and RPE. And for the last 4 minutes, we have a cool down period. So here again, speed will remain at 3 miles per hour, but you will reduce the grade percentage or the inclination to 0, just like the warm up for the last 4 minutes. And you will record the heart rate, the blood pressure, and the RPE again at 2 and 4 minutes for the cool down, and at 10 minutes and 12 minutes if you see the time of the whole test. I guess it's pretty simple, but still I want to summarize it at the end. The whole is for 12 minutes. Divided into 3 parts. The warm-up, 4 minutes. Cool down, warm-up 4 minutes. Exercise 4 minutes. Cool down 4 minutes. Speed will remain 3 miles per hour throughout the test. Grading for warm-up is 0. Grading for exercise is 5%. Grading for cool down is again 0%. And you will record RPE, heart rate, and blood pressure after 2 minutes throughout the test. So for the 12 minutes, you will record these 3 measurements 6 times. I think it's pretty straightforward. And if you still have questions, I'm more than happy to answer in the lab. We are done with our test. That's a great news. But the idea is that now we are going to talk about the lab activity. Today we are doing 2 lab activities. And for the first one, it is related to the step test. So you will enter some of the very basic informations as you have been doing throughout your datasheet entry about the name, the sex, the weight, the height, etc. And then for the raw data, first you enter the age predicted heart rate using the formula which I have talked before. Then you will have the resting heart rate for 15 seconds, which was before the step test. And then you have the recovery heart rate, which is immediately after the test from 0.305 to 320, the heart rate immediately after getting off the Queen step test. And then you have to use this recovery heart rate from here, and using this heart rate, whether you are a male or a female, just calculate the VO2 max. Now, once you get your VO2 max value, you have to get the percentile rank as well as the classification. I'll take a rough arbitrary number. Let's assume you are a male and your VO2 max value is 60. Now, I have to look percentile rank based on table 7.1. So table 7.1 says that if you are a male, you have to look for this male, and you have to look for your age group 20 to 29. So if you are 60, you are pretty near to this number 61.8, which means that your percentile is pretty near to 90. So you can either write 90, or because it's 60, you can just use your common sense and maybe write 88 percentile. And the rank or the classification has to be superior. So this is how you are going to interpret the percentile for the first line and the rank or the classification based on the rank in this table. For the percentile rank on table 7.3, we'll go here, and if we get a value of 60, this is definitely above 55. So your rank is definitely 90 and your percentile is definitely superior. So you will go back and put 90 here and superior here. So I'm just repeating, the percentile has to be the stuff written under the percentile column, and the classification, depending upon the table number, is the rank. And try to use your common sense and bring it as close to the nearest value as possible. For this data sheet, this is actually pretty simple. You will use the same age predicted heart rate max using the formula, which we have again talked. If you're not sure of the formula, I could just go back and quickly let you know. Okay, this is the formula where you can find the age predicted heart rate using 208 minus 0.7 into age. All right, and then we have to follow this 12-minute treadmill test. So the 12-minute treadmill test says that at 2 minutes, 4 minutes, 6 minutes, 8 minutes, 10 minutes, and 12 minutes, those 6 points where I told you to calculate the blood pressure, the heart rate, and the RPE, just write these numbers. So you have RPE, you have blood pressure, and you have the heart rate based on palpation. Speed, you are always aware that the speed is always 3, 3, 3, 3, 3, and 3. And if the grading is already given, depending upon the warm-up, it's 0, exercise, it's 5, and again the warm-up is 0. Just ignore this heart rate monitor column because we are not going to use any. That's all we have for today. Let's go on and discuss the summary. We have talked about the submaximal exercise testing, what is its definition, and how it is different from the maximal exercise testing. We have talked a bit about the importance of the topic and discussed that how the cardiorespiratory fitness and the circulatory and the respiratory capacity of an individual or health of an individual can be determined using this test. Then we have a couple of graphs where we talked that how heart rate is directly proportional to VO2 max, and this can be extrapolated to get the VO2 max or exercise capacity of an individual. We have also seen that how trained individuals have lesser heart rate to achieve more work because of increased ventricular mass. We have talked submaximal testing, talked about a few assumptions. I told you some of the sources of error which can be possible once somebody is exercising on a step test or doing a treadmill test. I've talked about the RPE scale which you will use, and I have repeated many times the indications to stop the exercise test. Then we have discussed the two big tests which we are going to perform in the lab today, the Queen College step test and the steps for the Ebling exercise treadmill test. And I walked you through the data sheets 10.1 and 10.3, and I hope that you will be able to fill in all these data sheets and details without much difficulty. Hope you had a great time watching this video, and I will see you soon once we'll discuss our next video. Thank you very much.